Hello, fourth graders. Welcome to our review of Unit 5. Wow, Unit 5, we've learned a lot. It's kind of been a long unit, hasn't it? But we have really talked a lot about fractions. Okay, fractions, mixed numbers, and all of those different things. And we're going to review those here today. Our first one to review goes way back to our very first lesson in this unit that says, write an addition equation to show 5/8 as the sum of unit fractions. All right, so do you remember what's special about unit fractions? Unit fractions have a 1 as the numerator. So if we had to write an addition equation to show this, we would write 1/8 plus 1/8 plus 1/8, that's 3, plus 1/8 plus 1/8 equals 5/8. Right? We do have to include that equal sign because that's something that makes an equation. When you tell an equation, we're telling something that is equal. So that is our sum of unit fractions. So down here, we get a chance to decompose some fractions. We're going to do them in two different ways. Okay, so now we could do unit fractions, that would work, or we could change them around, right? So that, we don't have as many unit fractions. So I'll do the first one and you'll do the second one for each one of these. So to make 7/8, I could do 3/8 plus 4/8 equals 7/8. All right, what else could we do to get 7/8? We could do 2/8 plus 5/8. Would that work? That would work. Or if you did something different, as long as it equals 7/8, then that's all we need to know. Now, when we have this mixed number, right, we need to think about, well, if this 1 right here, that is worth 6/6. So really here we have 6/6 and 5/6, which equals 11/6. So whatever we do here needs to equal 11/6 because that's what this equals. So I could do 10/6 plus 1/6, and that is equal to 1 5/6, or equal to 11/6. All right, what's your second one? Okay, lots of different possibilities. One favorite that students like to do is 6/6 plus 5/6, right? Represent the whole number here, add the fraction here, and now you have 1 5/6. So this is decomposing numbers. Remember, decompose is where we take something apart. All right. Let's use some manipulatives or drawings to help you solve the problems. Now, some of these, I think that you know the math well enough now. If you want to pull out the fraction circles or grab those online, you are welcome to do so. Here's our word problem. Maggie, Kim, and Joe shared a pizza. Maggie ate 3/8, Kim ate 1/8, and Joe ate 1/8. How much of the pizza did they eat altogether? All right. Got to have that picture in your mind. What do you see right now in your mind? See them all eating pizza. And what do we need to know? What do we need to know? We need to know what they ate together, right? Which is going to be an adding problem. So we're going to be adding 3/8 plus 1/8 plus 1/8. And I want to remind you to keep all of these denominators the same. What would our answer be to this problem? Did you say 5/8? If you did, you are correct, right? If you could draw that as a picture, you could draw out the pizza, right? You could put it in 8 pieces if we want to prove our answer that way. And then 1, 2, 3/8 plus another 1/8 plus another 1/8. That's 5 out of the 8 pieces. How about this one? Oh, there's our answer spot. 5/8 pizza. Take a look at this one. And I want you to tell me what the equation that we should use, meaning, or what the math problem is. You don't have to solve it yet, but what do we need to do for this problem number 5? Okay, we need to add these together, right? Because we even have the word here together. They're using some flour, and then she's using some more flour to make some cookies. So we're going to put this together. 1 1/4 plus 2 2/4 equals, how about C for cups? This is our unknown. This is called a variable. Right? We use a variable. You know, and last year you probably put a blank there or a question mark. Now we're using variables, right? The variable is a letter that actually does stand in place for a number. When we add these two, I bet that a lot of folks have already thought about this. We need to make sure that we add the fractions first. So add this 1/4 plus 2/4 and tell me what your answer is. Okay, did you get, well, I didn't add that first, actually. I added this first, so I'll write it down first. 3 3/4 cups of flour. Does that fit the sentence? The question. Let's look. How much flour did they use together? They used 3 3/4 cups of flour together. Yeah, that totally fits. Okay, when it fits, we go with it. All right, a little more practice here. I'll kind of talk through some of these, but you'll talk through most of them. Well, I guess you won't talk, although you could talk to yourself. How much here for this number 6? 5/7. All right, let's rewrite this. I'm just going to put this under here. Plus 3 3/8. How much for number 7? I got 8 4/8. Now, this is right, but if you reduced this, right, 4/8 is equal to 1/2. So the best answer is 8.5, but they're both still correct. How about number 8? How much? 11/9 is how much this could be. That's a correct answer, but that is an improper fraction. So the best way to do this is to take out 9/9, right? Remember, 11/9 is the same as 9/9 plus 2/9. So this is 1 whole, 1 2/9. This is the best answer, and I think in 5th grade you'll always be asked to give the lowest terms simplified answer. Here we go. Go ahead and take a moment and do number 9. Okay, when I added these up, I made sure that I put this under here. And I got, that's supposed to be a 6. 6/5, 3 6/5. Right? Another improper fraction. 6/5 is the same as 5/5 and 1/5. So I'm going to take that 5/5 over and give it another whole. 4 1/5 is going to be our best answer there. All right, let's talk about number 10. Remember, look here. We have 2 different denominators on the bottom here. Okay, and when we have 2 different denominators on the bottom, we have to change one of them to match the other. You cannot add apples plus oranges and equal bananas, right? That's this is apples, this is oranges, and you can't just say but the answer is bananas. We have to have all apples or all oranges. So we're going to take this 3/10 and we're going to think of what it could be equivalent to. Right? So if I had 3/10 and I wanted to change it into hundredths, well, I could do times 10 on the bottom and times 10 on the top. So 3/10 is actually also equal to 30 hundredths. Now I have 30 hundredths plus 60 hundredths equals 90 hundredths. Now, something else I could have done, I could have changed 60 hundredths into 6/10, right? And then 3/10 plus 9/10 would be 3/10 plus 6/10 would be 9/10. And that would be a right answer also, which is because it's equivalent to what we see here. All right. Aha. Subtraction sign. Go ahead, subtract that. What do you get? Okay, 2/4 or 1/2 And 3 more computation problems. When we say computation, we're talking about just straight subtracting. All right, how about number 12 here? Okay, 2/6, which is equivalent to 1/3. How about, oh, here we go, stack them. If you don't have a piece of paper out yet, you're going to need that notebook here. Okay, so you're going to subtract the fractions first. Tell me what you get. All right, I got 3/7 here and 2. Oh, that was nice. I didn't have to borrow. Those ones are nice and, not as much to think about here. All right, how about this guy right here? What do you think? All right, let me tell you. If you put 2 and 3/9, that is incorrect. And here is why, right? We have this problem to start off with. This says 4/9 minus 7/9. The bigger number is on the bottom. When the bigger number is on the bottom, you have to borrow the same way that you do when you're doing regular subtraction, right? If you have 72 minus 18, you can't do this. You can't just flip it around. Okay, subtraction, the order is very important. With addition, you can flip them. You can, 2 plus 3 is the same as 3 plus 2. But that is not true with subtraction. So this is how you borrow, right? Because this needs, if the big number is on the bottom, we're going to borrow. Big bottom, borrow. We're going to borrow we're going to borrow 1 whole here, right? Now that 1 whole is actually worth 9/9. And those 9/9 are going over here. So we're still going to have 9ths. And when you're trying to figure out what goes on top, just add those 2 numbers together, right? Because you had 4/9 plus 9/9. So you have, what number does go on top there? 13/9. All right. So now we can do the answer. Now tell me, your answer might be the same if you think you got it right, or you now might have changed your idea. What do you think the answer is now? It is 1 6/9, or 1 2/3 is an equivalent fraction. Okay, so lots of computation problems, lots of learning what to do with these fractions. Okay, all right, number 15, read that to yourself, and then I want you to tell me if this is an adding problem or a subtracting problem. This is a subtracting problem. This is a subtracting problem because we are asked to find the difference between 2 things. How much more? How much less? How much bigger? How much faster? How much slower? Those are all comparing questions, right? You have to figure out, you're comparing the 2 things, not adding them together, but comparing them. And whenever you're finding the difference, you are subtracting. Okay, and we would get 4/8 here, which is equal to 1/2. Here we have Gianna. Gianna lives 6 1/5 blocks from the library. She lives 2 3/5 blocks from the library. How much farther from home is the library than her school? All right, what about this one? Is this adding or subtracting? Another subtracting problem. How much farther, right? How much more? How much bigger? How much taller? How much whatever, right? We're finding the difference. So we need to do 6 1/5 minus 2 3/5 equals, our unknown. I think I forgot to do that on the top one up there. B for blocks. All right, you get another shot at these subtracting mixed numbers. Go ahead. What do you think? Okay, did you notice that you have to borrow? Big bottom borrow. 5 here. So we're giving over 5/5. So we have 5 plus 1. We have 6/5 there, right? That 1 whole that we took away was worth 5/5. So we had 1/5 there. 5/5 plus 1/5 equals 6/5. And then we just subtract. Did you have 3 3/5? If not, that's all right. I want you to understand why, though. Be a good thing that you can practice before our test coming up soon. Line plots here. All right, we're going to be creating a line plot. What was something important about a line plot? Okay, it uses X's, it has a title, you label whatever it is that you're talking about. Lots of things are important about a line plot. So let's read about this one. Use the data in to create a line plot and answer questions about it. The students in Mr. Caleb's class measured their thumbs to the nearest half centimeter. The measurements they gathered were, all right, so here's their data. Make a line plot displaying the data. Be sure to include a title. All right, how about title of thumbs? Capital T, right? Got to have a capital T there because it is a title. Whoops. I put that back. Let's see. Magic button. Yay. All right, now how am I going to decide where to put these things? Because look, there's no label, there's no numbers down here yet. So I know that the smallest one is going to have to go right there. So as I look through this, the smallest one I see is 3 1/2. So I'm going to put 3 1/2 right here. And then this would be 4. This would be 4 1/2. See, I'm just counting by halves. 5 and 5. Whoops. 5 and 1/2. Okay, so I had to find the smallest one because I knew that it would go there. Now, what are these? 5 1/2 what? They measured to the nearest centimeter. All right, so centimeters. I have to label my centimeters. CM, not CN. CM, 4 centimeters. Let's put the line plot on. 3 1/2, I see 1, 2, 3 of those. So 3 X's. 1, 2, 3. How many 4s do we have? 1. 1 4. So we'll put that on here. How many 4 1/2s? 1, 2, 3, 4. See how I cross these out? I'm going to really ask you to do that because it's really, really helpful. It helps you to see what's left. 5s. 1, 2, and I can see 1 5 1/2. So I can go ahead and do both of those. 1, 2, and one of these was left. What is the length of the longest thumb? Okay, the longest thumb. If you said 4 1/2, that's the tallest stack. But the longest thumb is over here. Somebody has a thumb that is 5 1/2 centimeters long. So our longest thumb is 5 1/2. I bet the question that's next is what is the shortest thumb? Ha! I was right. What's the shortest thumb? 3 1/2, right? This one, shortest. If you said 4, no, the 3 1/2 is shorter than 4. All right, 3 1/2. Oh no, I moved it. There we go. The undo button exists, aren't you? What is the difference? Subtract in the length between the longest and shortest thumbs. Write a number model. All we have to do is subtract these two. That's nice. I can do that. Minus 3 1/2 equals, and our answer will be it will be centimeters. How much is that when you subtract those? 2. Yep, right. 1/2 minus 1/2 is nothing. So 5 minus 3 is 2. All right, I'm going to skip the turns real quick here, right? Because I want to make sure that we have time to get down here to these angles. All right, look at this angle. Is this an acute angle, an obtuse angle, or a right angle? This is an obtuse angle. Let me check and make sure. Oh, yep, we're still recording. That's good. Obtuse. So I'm going to write obtuse here. And then that tells me that this is more than 90, but less than 180. If I had to estimate that, what do you think? How much do you think that is? Yeah, it's about, I'd say maybe 140. If you said 150 or 160 or 130, you're in the right range. Now, if you said 12, no, that would be an acute angle. 12 would look like that. Okay, and so you have to think about what kind of angle we have here and how you would estimate that. Here we have, what kind of angle do we have here? We have acute. And so what measurement would this have? What range here? All right, and then if I had to give an exact estimate, 45, maybe 40. Maybe 35, but I don't think so. Right? We can estimate the amount that they're open. Remember, a right angle is open 90. So this angle is less than 90. The angle up here is open more than 90. So use what you know. All right, we've got some lines of symmetry. All right, how about this triangle? How many lines of symmetry do you see? I see 3. 1, 2, 3. Sometimes people forget about the other ones. On this pentagon, because it's a regular pentagon, we have 5. 4, 5. All right. How about the last one, that parallelogram there? Oh, trick question. There are none. No ways could you fold that and get it to match. If you don't believe me, trace it, cut it out, and see if you can fold it and make it match exactly. Okay. And then here is our last one, our symmetric shape. We're going to draw the rest of that shape to make it work as well as we can. Okay. Now, I'm not going to go over this last problem because the video is lasted long enough, but what I want you to remember is our steps for solving these problems, right? We need to understand the problem, meaning that we visualize that and that we understand what's going on in the problem. Because if you don't do that, you're going to pretty much be toast, right? Then we want to look for a starting point. And then when we get to the end, we want to look back and see if we made an answer that actually fits the question that was being asked. Okay, so you'll be working on something. You'll have a question like this on the test coming up soon. All right, that was a long video, but remember, there's no math journal page here. So this is 2 birds with 1 stone. Good luck on your Unit 5 test. If you're not ready, right, look for maybe strands on IXL or videos that go with the topics that maybe you think you need a little more practice with. All right, good luck.